Imagine you launch a brand new food delivery startup. You build a sleek website for customers to browse menus and place orders, and behind the scenes, you create a private admin panel for restaurant owners to log in and update their listings. You deliberately leave this admin portal off the homepage. There are no links pointing to it. You assume that if a web page isn't publicly linked anywhere, attackers simply won't be able to find it. But that assumption ignores how modern attackers actually operate. Hackers don't browse websites manually. They run automated tools, and all they need is a single piece of public information to begin a full-scale breach: your domain name. Relying on secrecy instead of actual defense is a concept known as security through obscurity. It traps countless new developers, inviting automated systems to systematically uncover and dismantle their defenses. An attacker starts with nothing but the web address. To attack the site, they first need to find the physical server hosting it. A simple terminal command, like a DNS lookup or a ping, instantly translates that public domain name into a specific IP address. With the target's location pinned down, the attacker performs a port scan. This is exactly like walking around a target's house, testing every single door and window to see which ones are left unlocked. This diagram shows the scan's results. Out of thousands of possible entryways, a network scanner reveals that one specific gateway, port 80, handling HTTP traffic, is actively open and responding. Port 80 is doing exactly what it's supposed to do, serving the public-facing menu and order pages. But the attacker isn't interested in the public site. They want the hidden back-end infrastructure sitting on that exact same server. Mapping these active network ports is the mandatory first step of an intrusion. It provides the precise coordinates attackers need to deploy their automated discovery tools. To find those unlinked files, attackers use directory brute forcing. Instead of hunting for visible links, they rapidly guess thousands of potential folder names. This diagram shows how automated enumeration tools execute this guessing at high speeds, rapidly feeding potential directory names into a scanning mechanism and firing them at the server URL one by one. The ammunition for these scanners comes from word lists. These are massive text databases compiled from leaked data and common developer naming habits, filled with obvious paths like admin, config, or test. The server's automated response codes give away the hidden structure. If the scanner tries a folder like backup and gets a status code 403 forbidden, the attacker knows the folder exists, even if it's locked. But if a guess returns a 200 OK status, the page exists and is completely accessible. Within minutes, the scanner hits a 200 OK response on a file called admin.php. The hidden logging cage is exposed, proving the founder's initial assumption wrong. Developers cannot hide files or folders from automated scripts. These programs systematically test every possible URL path, turning a guessing game that would take a human years into a process that takes minutes. Finding the admin page is only the first step. The attacker now faces a login prompt with no obvious way through. There are no password hints and no forgot password links to exploit. Instead, they turn to login cracking software. These programs are designed to pair thousands of possible usernames with thousands of passwords, automatically submitting them into the form field. Attackers load these cracking tools with highly specific text files. They use default vendor usernames, like the word root or the word administrator, and combine them with lists of the most commonly used weak passwords found online. This diagram illustrates the core mechanism of the attack. The cracking tool knows an attempt failed because it reads the site's own failure response. It scans the page for the exact text string, incorrect username or password. The software cycles relentlessly until it inputs a combination that doesn't trigger that error. It abruptly stops and reports the successful match: administrator, paired with the password, I love you. A login screen backed by a weak password offers zero mathematical protection against high-speed, automated credential stuffing. The attacker enters those discovered credentials, bypasses the login screen entirely, and gains full, unimpeded access to the startup's admin dashboard. The real-world cost is immediate. A live customer database packed with highly sensitive user data, names, emails, and phone numbers, is now sitting perfectly visible in the hands of a complete stranger. Hiding isn't securing. Any sensitive data protected only by obscurity and weak passwords will inevitably be extracted by automated tools that never sleep. Think about the login pages you interact with every day. What is the absolute worst password you have ever encountered in real life? Let me know down in the comments, and subscribe for more deep dives into digital forensics and cybersecurity.